In this episode, we focus on a foundational truth that is easy to overlook when people get excited about models and automation. If the data is weak, the output is weak, no matter how impressive the AI system seems. For brand new learners, it can be tempting to treat a model score as a fact, like a thermometer reading, because numbers feel objective. In reality, model scores are produced by patterns learned from data, and those patterns reflect whatever the data contains, including mistakes, gaps, bias, and outdated assumptions. Auditing data quality is therefore not a side task for perfectionists. It is the most direct way to protect the business from unreliable decisions, unfair outcomes, and hidden security and compliance failures. Domain 3D expects you to evaluate whether the data feeding the AI system is accurate enough, complete enough, current enough, and controlled enough to support trustworthy outcomes. By the end, you should be able to explain what data quality means in an audit context, why it matters for AI reliability and fairness, and how auditors gather evidence that data quality controls are real and effective. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Start by separating two ideas that beginners often mix together: data quality and data security. Data security is about protecting data from unauthorized access, tampering, and loss. Data quality is about whether the data is fit for the purpose the system is using it for. A dataset can be perfectly encrypted and tightly controlled, and still be low quality if it is full of errors, missing fields, inconsistent definitions, or outdated records. In AI systems, low-quality data becomes a risk because the model learns from it or relies on it to produce outputs, which means the system can confidently repeat mistakes at scale. This can create business harm even without a breach, such as denying service unfairly, generating misleading guidance, or misclassifying events in a way that delays response. Auditing data quality means asking whether the organization has defined what good data looks like for this use case, and whether it has controls that keep data within those expectations over time. If you do not audit data quality, you are effectively trusting the model to compensate for weaknesses it cannot reliably fix. For beginners, the key mindset is that AI does not magically cleanse reality. It reflects reality as encoded in the data. Data quality has several dimensions, and you do not need advanced math to understand them. Accuracy means the data values match reality, such as correct labels, correct categories, and correct outcomes. Completeness means important fields are present and not systematically missing for certain groups or situations. Consistency means the same concept is recorded the same way across systems and time, rather than being coded differently by different teams. Timeliness means the data is current enough for the decision being made, because stale data can produce wrong answers even if it was once accurate. Validity means values follow expected rules, such as dates being real dates and categories being within allowed sets. Uniqueness means duplicates are controlled so the same entity is not counted multiple times in misleading ways. In an audit, these dimensions become criteria because you can test whether the organization checks and maintains them. For AI, each dimension matters because models can pick up patterns from errors and inconsistencies, and they can amplify those patterns into outputs that look authoritative. Auditors focus on what dimensions matter most for the specific use case, because not every dimension has equal importance in every system. A practical way to audit data quality is to begin with the business question the model is trying to answer, because that tells you what data must be trustworthy. If the model scores risk, you need to know what risk means in business terms and how it is represented in data. If the model classifies support tickets, you need to know what the categories mean and whether labels were applied consistently. If the model is used for eligibility decisions, you need to know which fields are considered and whether they are accurate across populations. This business-first approach prevents a common audit failure where the auditor checks generic data quality metrics without understanding whether they matter. Data quality is not about producing perfect data. It is about producing data that supports decisions without predictable harm. That means the audit must connect data fields to decision outcomes and identify which data elements are critical, which are supportive, and which are irrelevant. Beginners sometimes treat data as a giant pile, but a good audit treats data as structured evidence tied to specific decisions. Once you know the critical data elements, you evaluate data provenance, which is where the data came from and how it entered the system. Provenance matters because you cannot judge quality without understanding sources and transformations. Data may come from internal operational systems, customer inputs, partner feeds, or vendor datasets, and each source has different quality risks. Internal systems may have inconsistent entry practices and legacy fields. Customer inputs may have errors, omissions, and intentional manipulation. Partner feeds may have mismatched definitions and delayed updates. Vendor datasets may have unknown collection methods and hidden bias. In AI, provenance is also tied to the question of what data influence training or fine-tuning, because training data quality shapes the model's baseline behavior. Auditing provenance involves collecting evidence of data source documentation, data dictionaries, and lineage records that show how data moved and changed. The goal is to be able to answer for any critical data element, where it came from, who owns it, and what transformations were applied before it reached the AI system. Without provenance, quality controls become guesswork. Label quality deserves special attention because many AI systems rely on labeled examples, and labels are often where hidden errors accumulate. A label might represent a category, a decision outcome, or an assessment like fraud or not fraud. If labels are inconsistent, biased, or based on weak criteria, the model will learn those weaknesses as if they were truth. Auditing label quality means asking how labels were created, who created them, what guidance they used, and how consistency was checked. It also means checking whether labels reflect the outcome the business actually cares about or merely a proxy that is easy to measure. For example, if a model is trained to predict whether a case was escalated, it may learn the escalation habits of staff rather than the actual urgency of the case. That can embed human bias and process drift into the model. A good audit examines whether labeling processes were controlled, whether disagreements were resolved consistently, and whether periodic reviews are performed to catch drift. Beginners should understand that label quality is not just a data science detail. It is a governance issue because labels encode business judgments into the system. Bias and representativeness are central data quality concerns for AI audits because data can be accurate in a narrow sense, yet still produce unfair outcomes. Representativeness means the dataset includes enough examples of the populations and situations the model will face in the real world. If some groups are underrepresented, the model may perform worse for them, which becomes a fairness risk. Bias can also appear when historical data reflects unequal treatment, and the model learns to reproduce those patterns. Auditing for representativeness does not necessarily require using sensitive demographic data in every case, but it does require examining whether the data covers the relevant contexts, languages, regions, and edge cases. It also requires checking whether data quality issues are unevenly distributed, such as missing fields being more common for certain groups, which can lead to systematically worse outcomes. Auditors can examine sampling strategies, distribution reports, and quality checks that compare segments, looking for gaps that matter to business risk. For beginners, the important idea is that data quality includes fairness risk because a model can be reliable on average while harming specific groups consistently. Data quality auditing also includes examining how data is updated and maintained over time, because timeliness and drift are constant challenges. Businesses change, customer behavior changes, and the meaning of categories can evolve. If the dataset is not refreshed appropriately, a model may rely on outdated patterns and produce wrong decisions. If the dataset is refreshed without controls, new errors can be introduced, and the model may drift unpredictably. Auditing this area involves examining refresh schedules, validation checks performed during refresh, and controls that detect distribution shifts. It also involves checking whether the organization monitors performance and fairness metrics over time and uses those signals to trigger data review. In AI contexts, an organization may need to manage both training data updates and retrieval data updates, which are different but both affect outputs. Training data updates reshape the model's learned behavior, while retrieval data updates reshape what information the model can access and summarize. Both can introduce quality risks, and both should be governed. Beginners should remember that data quality is not a one-time cleansing project. It is a continuous control process. Another key audit area is data definition consistency, which is a less glamorous but extremely common source of model failure. Different systems may use the same word to mean different things, such as active customer, resolved incident, or high risk. If the AI system combines data from multiple sources with inconsistent definitions, the model may learn contradictory patterns or produce unreliable outputs. Auditing consistency means reviewing data dictionaries, field definitions, and transformation rules to ensure concepts are aligned. It also means checking for silent changes, where a field's meaning shifts over time without clear documentation, which can break model assumptions. In AI, these semantic shifts are dangerous because the model can continue producing outputs that appear stable while underlying meaning is changed. Auditors should therefore look for governance practices that manage definition changes, such as controlled updates to data dictionaries and communication to model owners when upstream fields change. For beginners, this teaches an important lesson. Data quality is not only about correctness of individual values, it is also about shared meaning across systems. You also need to evaluate the controls that enforce data quality, because an audit is not only about describing problems, but about determining whether the organization can prevent and detect them. Data quality controls can include validation rules at ingestion, automated checks for missingness and outliers, deduplication processes, manual review for critical labels, and exception handling when data fails validation. Controls also include ownership and accountability, such as data stewards or owners responsible for maintaining quality. In AI audits, it is important to check that quality controls are integrated into the pipelines that feed training and deployment, not performed as occasional manual cleanups. Evidence might include quality reports, failed record logs, documented thresholds for acceptable quality, and records of corrective actions taken when quality issues were detected. Another important control is quarantine, meaning the ability to prevent bad data from entering the system until it is reviewed. Without quarantine, the organization may detect quality issues only after the model behaves badly. Beginners should understand that controls make data quality real, because without controls, quality is a hope and a promise rather than a managed property. Finally, remember that data quality must be evaluated in the context of trust decisions, because the entire point is to decide whether outputs should be relied on and under what conditions. Auditors should connect data quality findings to the business outcomes the model influences, explaining how quality weaknesses can lead to specific harms like unfair denials, incorrect risk flags, or misleading summaries. This is where the audit becomes valuable to leadership because it translates data problems into risk language. It also allows the audit to recommend practical remediation, such as improving labeling guidance, tightening validation rules, expanding representation in datasets, aligning definitions across systems, or strengthening monitoring for drift. The audit does not need to promise perfect outputs. It needs to clarify whether the organization has enough data quality discipline to justify relying on model scores for the intended purpose. If data quality is uncertain in high-impact areas, the audit may recommend additional human oversight or narrower use cases until quality improves. That kind of recommendation is grounded and responsible because it ties trust to evidence. As we wrap up, keep this central idea. You should never trust an AI output or model score more than you trust the data and processes that produced it. Auditing data quality starts with clarifying the business decision the model supports, then identifying the critical data elements and their provenance. It examines label quality, representativeness, and bias risk because those shape fairness and reliability. It checks timeliness and drift controls because data changes, and so do business conditions. It validates definition consistency because mismatched meanings can break models silently. It evaluates enforcement controls like validation, monitoring, and accountability so quality is managed rather than assumed. When you audit data quality this way, you are not criticizing data for being imperfect. You are protecting the organization from treating uncertain data as certain truth. That is exactly what Domain 3D is aiming for, and it is one of the most practical skills an AI auditor can bring to any environment.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.